Okay, so let's start with another multilinear regression exercise. Now here we are using a housing data. So let's first clear the output from this with the help of this to restart and clear the output. So with this all the outputs will be cleared. Now you can check it, and then now we can start our exercise. So this multilinear regression with Boston housing data set. The data set belongs to the Boston, right? So let us run this. Nothing will happen. Import numpy as np pandas, and then since because we have to do certain exercises which we'll explain, we need these libraries also, model selection and train test split. Then we also need to this load of Boston data set, and then matrix for various kinds of measurements, and then of course the data itself. So let us run this so that we get all the libraries which are required for this purpose. So with this code, which you can see, where you can see the star in the process that is happening, it is doing all this, is importing all these libraries, and then of course it is also getting this data frame into df, right? So this is what is happening in this particular process. So once it is complete, it is already completed. Now we move on to the next process, and we now need to create an instance of the data set by calling the load Boston function, right? So in this of course the df, we are transferring the data, and it is a CSV file available in this particular say by the name of housing-1.csv, and header is none in this. So that means we can remove the header, because normally if you have a Excel sheet and you have saved the file as a CSV, the header is always there, so we can remove the header. That is why this code is mentioned as header none, right? You can see it here. Yeah, right. So this also we can run by clicking on this. So we can run this. It is done. Now let's print out the value of the data variables to see what kind of data it contains. So for that we have written this code, that is print df keys, right? So these are the keys of that. Then the data is all the actual information regarding the houses, while the target is the price of the house. The feature names are the names of the categories the data falls into, and description is a command to describe the feature of the data set. So we can run this again. This is for our understanding, so that is why this explanation has been given. So we move on to the next. No action has been taken here. Then we are trying to get the data and the feature names into the data frame our model can use. So let's create a data frame object from the data using pandas. We also pass in the feature names of the column headers. So this is again for our understanding. Now we are writing this code to get more understanding about the data. Now we will get some output with this. So with this you are getting all these details about the data. It is having 506 rows and 13 columns. These are the columns that you are seeing, and it is there, right? Now the next step we are going to see is to check for the data frame. So just to know the details of this. So just by doing this, you can see that the 13 columns are there, and then these are the top 5 rows and bottom 5 rows, and in between of course we can't display. If you want, you can get the complete details also, but this is how you can get a more familiarity with your data set. And you can see that 506 rows and 13 columns. Now we are transferring the data into X and Y. So with this command, with this code, you can do that. And here, as I explained earlier in the earlier tutorial, that is X, capital X is equal to PD data frame df.iloc. Here we are not putting any figure. This means that the entire data is being considered, and this -1 means that we are leaving we are starting from the last element, and the first, after the last element, the first element is -1. Similarly for y, we are taking pd.dataframe df.ilock, and then again nothing there in the first, and then the -1. So that's how you can get this, and this is very important. If you are not clear about it, you can go back to the Python basics, that tutorial, and you will get to know about it. So we can run this, nothing will happen here. Then we want to know about the contents of x, so we can run this, and you can see that all these details are going to be displayed here. Similarly for y also we can run, so we can get other details also, because that is our objective. Then from sklearn model selection import train test. Now this is where we are going to divide our data set into training and testing. So we are splitting it, and for that we have already imported the model selection library along with the train test split. And in that x train x test, y train y test, this is the data will go, and then train test split x y, test size is 0.2. 0.2 means that 20% of the data has been kept for the testing, and remaining 80% is for our training, because training you need more data. So for training we have kept 80%, and for testing we have kept 20%. And the random state is 5. Now this 5 indicate that there are going to be 5 iterations. So we can run this and see that this particular process has been completed now. Now we are going to print the details of this. X train x test, y train y test, and this is the shape of that. This is how you can get the details of them. Now you can see that x train has 404 rows and 12 columns. Similarly, the x test has 102 rows and 12 columns. Columns here are going to be same for one particular variable. Similarly, 404 and 1 for y, and 102 for and 1 for y another, right? Now from sklearn models import linear regression. Now this is also a sub library available in the sklearn itself, and this is the code we have to write for that. So from sklearn we are importing the linear regression, because we are going to compute the linear regression for that. So lin-reg mod, this of course in the short and this is the way it is to be written. So linear regression, and then we can run this, so we get this process also gets completed. Now we are going to have the lin-reg mod fit. Now we have to fit the model. This is the code you have to understand, you have to revise, you have to go through again and again unless you are clear about it. And this is the way you have to write the code. X train means that we are training the data which is there in the x, and also in the y, whatever data has been transferred with the help of the earlier code. And now we can run this. So once we run this, you are getting that linear regression copy x is equal to true, fit intercept is equal to true, and n jobs none, normalize is equal to false. So that means the job has been done with the help of this particular code. Now we are going to predict. Pred is the short form. The predict is equal to lin-reg mod predict x test. So because we have, as I mentioned, that 80% is for training and 20% for testing. So this whatever data has been splitted into x test, that is what we are going to check now. So we can run it, and this has been done. Now we have further no output will be there in this, but certainly now we have to go to the next process, that is from sklearn matrix import R2 score. Now that is again a library available in the sklearn matrix, and so therefore this is of course remark, but then from sklearn matrix import R2 square, then test set RMSE, that is root mean square error, np.sq square root mean squared error y test predict. Now this code again one has to go through again and again, and maybe you can understand it. So this is how you have to write the code. Then test set R2 is equal to R2 score y test pred. Now this is the way you have to write it, and then we can run it. So once you run it, again this process gets completed. Then print test. Now we have to whatever this test, in this test whatever has been transferred, now we are going to print it. Similarly for test set R2 here also. So both these we are going to print it now. So once we print it, you can see that it gives you the output, because after here we have transferred it here. It has not been printed here, but with this code we are getting it printed. So this is 4.46 whatever is there, and then for test we are having the 0.745295 etc. So this is the way you are getting this. Now note that for RMSE, that is root mean square error, the lower that value is, the better the fit is, right? And the closer towards 1, the better the fit is, like here you can see. So that is how you can say that our this code, our the result is correct, and there is a good the prediction for this data set that we have. This completes our multiple linear regression for the Boston housing data. Thank you.